Okay. So, hello, hey guys. Welcome to week 0 of this new course that is beginning soon. So this course is basically an NPTEL MOOC course, and this is a course on reinforcement learning. This is being taught by Professor Balram and Ravindran from IIT Madras. And today it's supposed to be just a week 0 dry run. What we are going to do is we are going to discuss the week 0 questions, the week 0 practice ungraded questions, which I think all of you must have attempted by now. If not, we'll just take a look at it, and we hope that by the end of this session, we are clear with the basics of what this course requires us to do. Okay. So I'll just quickly share my screen. Okay, and yeah, there we go. So you guys can see my screen, correct? If yes, just yeah. Okay, cool. Okay, great. So yeah, like I said, this is a course CS75. This is being taught by Professor Ravindran from IIT Madras. This is a combination. This is a joint initiative taken by NPTEL and Swayam, and we are going to look at the week 0 class and discuss the questions that come along with it. Okay. So before moving on, I should. It's only correct if I give you a quick introduction about me. So hi, my name is Manav Mishra. I am a PhD student at the ECS department at ISER Bhopal. Okay, and I am going to be one of the TA for this course as part of the NPTEL MOOC program. So I am one of your TA, and we'll be having weekly lectures starting on every Friday, starting from 7 p.m. and ending at 8 p.m. So I hope we get to interact with each other as the course goes along, and I hope I can also get to learn from you through these interactions, as well as you get to also learn from me. Okay, so I think that's a decent introduction to start with. So I'll quickly go to the week 0 assignment questions. There are 10 questions. We'll take like sufficient time with each question, and we'll only move forward if everybody is clear of what the answers should be, and if everybody is fine with the question. Okay, so since there are quite a number of people, in order to make sure that if people have understood or not, so if at every question, if you feel that you have understood that question, you simply raise your hand. So I know that you guys are fine with the question, you guys understood the question, and then I can move forward. This is just to make an effective management of the class in general. Okay, I think with this clear, we'll move to week 0 assignment, and we'll look at question number 1. Okay, I think this was one of the trickiest question in the assignment, because this problem is basically testing your knowledge in probability, your knowledge in set theory, as well as your knowledge in finding range in a minimum maximum setting. Okay, so I'll quickly just read through the question. The question says, I have been given 3 probabilities. P of A is 0.5, P of B is 0.7, and P of C is 0.9. What I'm supposed to find is the probability P of A union B given C. Okay, so I'll start by writing this. I have P of A union B given that I have C. Okay, so this is the probability question, and since this is a conditional probability thing, I'll quickly go on and apply the formula for conditional probability. Okay, so the formula for conditional probability is nothing but P of A union B intersection of C divided by P of C. There should be a small bracket over here around A union B, but since they are associative in nature, I'm not putting it, or maybe I should just put it just for completeness. Okay, so there's a bracket. It's basically the formula for P of X given Y. So I'm writing the formula, which is P of A union B intersection of C divided by P of C. So I know P of C, I know this thing. So if I have this formula for intersection, I can always convert it to a union, correct? So if I know intersection, of two quantities, I can always find the union. So there is a formula, right? P of x union y is nothing but P of x plus P of y minus P of x intersection y. Correct. So I'll probably write it say here. Just zooming it a bit. So I have P of A union B plus P of C minus P of A, sorry, P of A in union B union C, the whole divided by P of C. I think this is clear. How I have written this, correct? If not, you can just raise your hand so that I can explain it again. I think this is just the formula. I'm just using the formula for union intersection set. So I have this thing. So here I take a look. What are the quantities that I know and what are the quantities that I don't know? I know P of C in the numerator and the denominator. I don't know P of A union B, but I know P of A intersection B intersection C. So what is the value of P A intersection B intersection C? This value is nothing but 1, because these are the only three sets which are given to us. So this is one assumption that we are taking. That
union है.
Sorry?
Union है.
Sorry. So this is P A union B union C, right? So we are going with the assumption that since there are only three quantities which is given, the union of this three quantity should give me 1. So the probability that one of them is true should be 1. So this quantity I have taken to be 1. Okay. So and again I have this union term. I'll again expand it into its intersection term. Okay. So to simplify, I'll write this as P of A plus P of B plus P of C minus 1 minus P of A intersection B divided by P of C. I think what I've done is clear, right? I have just expanded this term into this, and this quantity.
Okay, I have one question here. Can I?
Okay.
So
Sure.
you're saying that P of A union B union C is equals to 1, right? But what if these three events are inside some universal set? It may not be.
So that's the assumption that I have to take, because otherwise I won't be able to solve this question. If not, I need to know this P of A union B union C. But since these are the only three sets given to us, so I assume that these three set is the entire universe as of now. This is the assumption. This is not explicitly mentioned in the question. Maybe they should have mentioned. But if you want to solve this question, I think this is one assumption that you have to take.
Okay.
So what I'll do next is I'll just put in the values. Okay. So just take a look. What is P of A is 0.5, P of B is 0.7, P of C is 0.9. So if I add these three together, I should get a 1.2 plus 1.9, which is 2.1. And if I subtract 1 from it, I should get 1.1. Okay. So if I look at it, I should get 1.1 1.1 minus P of A intersection of B divided by 0.9. This is what I get after substituting the values. Now all I need to know is this quantity P of A intersection of B, and if I know this value, then I can solve this question. Correct. So now all I need to look at, I should probably find out the maximum of this intersection of A and B, and the minimum of the intersection of A and B. Okay. So this is a maximum minimum question. So I should find out the maximum value that this quantity can take. I should also find out the minimum value that this quantity can take. So let's start with the max value. Okay. So if I want to look at if I want to find out the maximum value that this quantity that the quantity should take, that means I should minimize this quantity. I should minimize P of A intersection of B, correct? So if I want to minimize A intersection B, if I have two quantities and I want to minimize this quantity, then what should be the minimum value of A intersection B? Anyone?
0.
No, it can't be 0. The reason is, if I take it to be 0, the whole quantity turns out to be greater than 1. If I
Okay.
take it 0, I should get 1.1 divided by 0.9. This can't be 0. So that means this quantity is not disjoint. Do you agree with that statement?
That's again an assumption, right? No?
No, if it is disjoint, then intersection should be 0, correct?
That's right.
So if it is non-zero, that means there is some overlapping which is happening. If the intersection is non-zero, I can say that these quantities are not disjoint; they are overlapping with each other. Correct?
Yes.
Can I say that?
Yes.
Okay. So if I can say that, so let's assume in the case that A is completely inside B. Okay.
That's correct.
I say set A is completely inside B. If I assume that, then what should be the intersection? The intersection should be 0.5. Correct?
Yes, that's right.
If A is completely inside B, then the intersection should be 0.5, and that is a maximum possible intersection that I can take. Okay. So if I can do that, if I can take that maximum possible intersection, that means this quantity. That means this quantity that I have here, this should be minimized. Okay. So if I take P of A intersection B, and if I take it to be 0.5, so this is for the min value. That means I am maximizing this intersection quantity P of A intersection B. So in that case, what I get is 1.1 minus 0.5 divided by 0.9, and that comes out to be, my final answer comes out to be 2/3. This is the minimum value that I can get. Okay. And if I want to look at the max value, that means I should minimize the intersection quantity. So yeah, what should be the minimum of this quantity? We know that this is not 0, but this quantity should take a maximum value of 1. The whole quantity in itself cannot exceed more than 1. So this is only possible if this quantity P of A intersection B is 0.2. Can I say that? If it is any less than 0.2, then the whole probability becomes invalid. So the least value that this quantity can take is 0.2. So if I take this quantity as 0.2, then my max value becomes 1. Okay. So based on the minimization and maximization of this intersection quantity, I know my minimum value is 2/3 and my maximum value is 1. So that brings my answer to be this. Sorry. This is the answer for question number 1. So is this clear for everybody? If it's clear, please raise your hand so that I can move ahead. Okay. I'll move ahead. Okay, fine. I think it's clear. Okay, great. Thank you. Okay, so now I'll go to question number 2. The question is simple. I have a random variable x whose distribution is given below. The distribution is 3 times 2x minus 1 the whole square, and I need to find the expectation of it. I think this is a fairly straightforward question. All I need to know, if I want to solve this question, if I want to find out the variance of this quantity, I should basically know the formula with respect to expectation. So my variance of x is nothing but my expectation of x square minus the expectation of x the whole square. This is the formula we know for variance, correct? So if I know these two quantities, if I know expectation of x square and I know expectation of x, I can solve this question. So I need to find it out separately. Okay. Sorry. I'll just write here the expectation of x square expectation of x square is nothing but, sorry, I'll take the 3 outside. The expectation of x is nothing but integral from 0 to 1. This is x square. This is 1 plus 4x the whole square minus 4x dx. If I write it out properly, it should be x square plus 4x to the power 4 plus, sorry, minus 4x the whole cube dx. Because this is an integration from 0 to 1, I can probably directly solve it. I'll just write this as, so what is x square? The integration of x square. Integration of x square is x cubed by 3. And because it's from 0 to 1, I can directly write it as 1 by 3. Okay? So 1 by 3, sorry. Then plus 4x4, the integration is x by 5. X by 5 by 4. X by 5 by 5. So I have 4 by 5 x to the power 5. Because it's from 0 to 1, I'm taking it to be 1. And then this is nothing but x power 4, which is 1. So this is 1. So if you quickly solve it, can anyone tell me what's the answer? 1 by 3, 5 plus 12, 17, 17 by 15 minus 1 by 15. So this is nothing but 3 into 2 by 15, which gives me this quantity as 2 by 5. So my expectation of x square is 2 by 5. Now I only need to find out the expectation of x square. Sorry, the expectation of x. I need to find out the expectation of x. So I have 3 times. I'll probably skip some step over here because you can probably do it yourself. I'm just showing the working. This is integration of x plus 4x3 minus 4x square dx. If I integrate it, I should get x is nothing but x square by 2, which is 1 by 2, plus this is 1, this is plus 3 by 2, minus this is 4 by 3 x cubed. So this is 4 by 3. So if you solve this, what I should get? So I have 1 by 2 plus 1 is 3 by 2, 3 by 2 minus 4 by 3. So this is 9 minus 8 by 6, which is 1 by 6. So 3 into 1 by 6 is not, I should get 3 into 1 by 6, which is nothing but 1 by 2. So okay, I know these two quantities. Now I just simply need to put it in this equation. So what is p of x square? It is 2 by 5 minus the whole square of this quantity, ex the whole square. So 1 by 2 the whole square is nothing but 1 by 4. If I solve this, I get 8 minus 5 by 20, which is 3 by 20, which is option number 3. I think this question is clear. This was pretty straightforward. If you knew this basic, if you knew this formula, you could have easily solved this question. Okay. So I'll move to the next question if everybody is fine with it. If not, you can obviously unmute and ask me. Okay. So this is basically a knowledge-based question. This is a question: if x and y are random independent variables, which of the following is true? That means if I have x and y, they are independent and random variable, which of the following quantities should be true? So we know if the two variables are random and they're independent, that means their expectations are also independent. So E of xy is equivalent to expectation of x times the expectation of y. So this quantity is true. So this is not false. Okay. Then the covariance of x and y is equal to 0. Okay. So if I know if the two quantities are independent and random variables, their covariance is equal to 0. So this is also true. So this is not false. Also, the variance is also additive. If I want to know the variation of the quantity the variance of the quantity x plus y, it is equivalent to me knowing the variance of x and the variance of y and adding it together. Okay, so this quantity is also true. However, this quantity, it says the expectation of y given x. So it says the expectation of y given x. Okay, but since I know that x and y are independent random variable, this conditional probability won't make any sense for y. If I know about x, it doesn't affect my expectation of what I have on y. So this is equivalent to saying that expectation of y given x is equal to the expectation of y. So I can simply remove this bottom quantity. Correct. So this is the simple definition of conditional probability. And because I know that they're random independent, this quantity should be true. So here, but on the right hand side, they have given it to be e of x. So this is definitely false. And this is the answer for question number 3. Okay. So I think this is clear. We'll move to question number 4. Okay. So I have 4 examples with me, 4 functions. I need to know which of this is not a valid norm function. Okay. So norm function is something that you divide all the quantity with so that you normalize between some minimum and some maximum value. So the norm function has some following properties. Okay. The norm function should not be grid. First of all, the norm function should be non-negative. Okay. And the second is that the norm function should follow the triangle inequality. Okay. These are the 2 conditions that we have. So what is the triangle inequality? The triangle inequality says that if I know 2 sides of a triangle and the sum of the 2 sides is definitely greater than the third side of the triangle, which is f of x plus f of y is definitely greater than or equal to f of x plus y. Okay, this is the triangle inequality. Now, which of this do you think doesn't follow the triangle inequality? We can just take it case by case. For first quantity, okay, this is nothing but I xi the whole square. I goes from 1 to d. Okay, I'll just ignore that. It's just this thing plus this second quantity yi the whole square. So can I say that this quantity is definitely greater than or equal to the third quantity, which is nothing but x plus y the whole square? I can say that, right? Because any of this quantity can be negative, x and y can be negative, and the total summation would definitely be less than the individual sum of squares of the quantities on the left hand side. So this quantity is a valid norm function. So this is not our option. Now take a look at option B. This also I can verify if I take sum of xi plus the sum of yi. I can say that this quantity is greater than, sorry, this quantity is greater than xi plus yi. Correct? Since this follows the triangle inequality, and since this number is clearly non-negative, this is also a valid norm function. So this is not our option. Next, we are looking at the max and the min function. Okay. So I should have max of I xi plus max of yi. I can say that this is greater than the max of xi plus yi. I think this is also clear why this quantity holds, why this holds true. Okay, this is just a property of the max and min element, max and min element. Sorry. And last, just take a look at this. This is not the answer. So obviously we have only one option left. This should be the correct answer, but just for the sake of completeness, we'll just have a look at it. So I have min of so now here this equality, this quantity, this equation holds true I'll just write it here. Min of I, min of xi plus yi. Since this is a minimum, okay, this is not the maximum, here the opposite sign holds true. If I make it less than or equal to, then this quantity holds true. So clearly, this doesn't follow the triangle inequality. So hence, this is not a valid norm function. Okay. Other way to look at it is norm function is something that you divide each quantity by, and whatever the quantity that you have, this quantity should be less than 1. Correct. So if I divide anything by this quantity, because this is a sum of all the xi squares, the numerator will always be lesser than the denominator, and this quantity will be less than 1. Same goes for this. This is a sum of the absolute value of each individual xi's. If I divide it, then the numerator is definitely smaller. Any xi that I take is definitely smaller than this quantity. Same goes for the max. But if I look at the min value, I know that if I take the min value, the xi, which is not equal to the min value, is greater than that. So that's why I can say that the numerator is greater than the denominator. So that's why this can't be thought of as a valid norm function. So this is the answer for the fourth question. I hope this is clear. Okay. This is also a knowledge-based question. This is related to linear algebra. If you know about your theories of eigenvalues and eigenvectors, you can solve it. So the trace of the matrix M is the sum of its eigenvalue. This is definitely true. So this is not the correct answer. The determinant of the matrix M is a product of its eigenvalue. This is also true. This is a basic property of the eigenvalues, and this is also not our option. The real eigenvalues of M are distinct. So this may not always be true. I can always have real eigenvalues and they can be repeating eigenvalues. They did not be distinct. So this is definitely false. This should be our answer. And just to take a look at the fourth option, the rank of M is number of non-zero eigenvalues. This is the definition a rank of a matrix is. So this is also true. So this is not our answer. So this is question number 5. Moving on, I have A, which is a square non-singular matrix with eigenvalues A1 for eigenvector x. If I were to write it, it should look A of x gives me lambda 1 of x. Okay, this is what it says. And B is a square matrix with eigenvalue 2 for the same eigenvector. So I have B of x is nothing but lambda 2 of x. Okay. Now, what is the corresponding eigenvalue for the matrix A inverse dk for eigenvector x? So all I need to do is I should find out A inverse. A inverse B power k A for eigen this thing. I should compute its value. Okay. So whatever the operator, whatever matrix comes on the right hand side when we make a composition of these operators, that gets operated on the eigenvector. So first I should operate this with A of x. So if I operate this with A of x, I should get lambda 1 of x. So this lambda 1 comes out. I'm left with A inverse B of k and x. Okay. Next, I should operate B of k with x. If I operate that, and since I know that if my operator B has eigenvalue lambda I, then the operator B to the power k should have the eigenvalue lambda to the power k. Okay, this is a simple property. So if I solve it further, I should get lambda 1 times lambda 2 to the power k, and I'm left with A inverse of x. Okay, so since I'm dealing with the inverse of the operator A, so the eigenvalue that I get should also be the inverse of whatever value that I was supposed to get. So if I solve this further, I should get lambda 1 times lambda 2 to the power k, and this is nothing but lambda 1 inverse. Okay, so this quantity and this quantity cancels each other, and what I'm left with is nothing but lambda 2 to the power k. So this is sorry. So the correct option is option 2. Okay, so this is question 6. Quickly move to question 7. I think this is more of a mathematical question. I won't do the calculations. I'll just tell you the formula, then I'll quickly give the answer. You can probably verify with it. So all I need to do is I just need to expand it. And the important statement here is that x1 and x2 are two independent random variables. Okay. If I do that, I have, if I expand this a minus b the whole square, I should get x1 square plus x2 square minus twice of x1, x2. Okay. And now, since we know that the expectations are, they follow linearity, so I can split the expectations as follows. I can get expectation of x1 square. I can get expectation of x2 square minus twice of expectation of x1 times expectation of x2. So you understand how I did that? I did that because expectation of x1, x2 is nothing but it's the expectation of x1 and expectation of x2. And this only holds true if I know that the random variables that I have are independent. Okay. And now since I have that, I have expectation of x square, x1 square, expectation of x2 square. Do I know this quantity? Yes, I know the variance. So I know that variance is nothing but, variance of x is nothing but expectation of x square minus the expectation of x the whole square. Okay. So since I want to know this thing, so this expectation of x square is nothing but expectation of my x square is nothing but variance of x plus the mean x whole square. I can say that, right? So I'll just quickly write it. So this is the nothing but the variance plus mean square. So for x1, my variance is 5 and mean is 1. So this is 5 plus 1 square. 5 plus 1 square is 6. Plus here, this is 8 plus 4 square. 4 square is 16. 16 plus 8 is 24. This is 24 minus twice of the mean of x1 and mean of x2. This is 1 and 4 respectively. So this is times 1 times 4. So if I compute it, I get 20 plus 24 plus 6 is 30. 30 minus 8 is 22. So the answer to this question is 22. Okay. So this is question 7. Moving on. Okay. So here you're playing a game in which you have two bags. Okay. And they have colored balls. So I'll just draw it if I may. This is bag 1. This is bag 2. Okay. So here you have certain colors. Okay. So bag 1 contains 5 red balls, 4 green balls, and 4 yellow balls. They have points 50, 25, and minus 30. And the bag 2 contains bag 2 contains 4 red balls, 7 green balls, and 5 yellow balls. And the respective points for selecting each is 30, 30, and minus 20. So the game is that I am given a choice. I am given a choice of selecting either bag 1 or bag 2, and I can get a certain ball out of it, and whatever ball I get, I'll be awarded that much point that I have. So since I'm playing this game, I need to select which bag I should choose so that I can maximize the number of points that I can get. So here they say that you can refrain from playing if you want to stay on 0 points. So how do I choose which bag to choose? So I should know the expectation of winning if I select bag 1 and the expectation of winning if I select bag 2. Okay. I should know the expectation of whatever points I should get given that I select bag 1. So let's say I select bag 1. Okay. So what is the probability that I'll get a red ball? It's nothing but 5 by 13. Okay. Because I have 13 balls in bag 1 and probability of getting red is 5 by 13. And the point for red ball is nothing, is 50. Okay. Next, I'll add it with 4 by 13 for green ball, and I get total of 25 points, plus I have 4 by 13 into minus 30. Okay, this is the total expectation if I select bag 1. So if I do that, I should get 5 into 50 is 250, 250 plus 100 is 350, 350 minus 120 is 230. Okay, so the total here, the total here is 230 divided by 13. This is the expectation of bag 1. And then if I similarly compute the expectation of bag 2, I should get, so here the total number of ball is 7 plus 5 plus 4, which is 12 plus 4, 16. So total number of ball is 16. So for red ball, it should be 4 by 16 into 30 plus 7 by 16 into 30 plus 5 by 16 into minus 20. So if I compute it, 30 into 4 is 120, 30 into 7 is 210. 210 plus 120 is 330, and 330 minus 100 is 230. So what I get is, sorry. So what I get is, this is nothing. This is 230 divided by 16. Okay. So this is the two expectation that I get. So clearly I see that the expectation of the total expectation of the total points I can receive if I select bag 1 is greater than whatever the expectation of point that I'll receive if I select bag 2. So here clearly, since this number is greater than this quantity, so here my answer is bag 1. I think this is clear to all. So we are done with question number 8. We'll move to question number 9. Okay, I think this is a fairly simple question. Question says that I have a stick of length L. Okay, and this is broken at a point which is chosen uniformly, so that I can divide it into two parts, which is a stick with there's a larger end of a stick and there's a smaller end of a stick of the stick. So I have a larger piece, I have a smaller piece. So I need to find out the average length of the smaller piece. Okay. So if I just think of it intuitively, if I break this stick into two parts, what is the maximum length of the smaller piece and what is the minimum length of the smaller piece? Okay, just draw it again. So if I have a stick of length L and I just cut it somewhere, what is the minimum length of the smaller piece and the maximum length of the smaller piece? So if I were to write the range, of this piece is, the range of the smaller piece, should be within this range, correct? So the minimum value, it can be like something greater than 0, like almost 0.001, and the maximum value it can take is L by 2, because beyond L by 2, then it no longer becomes, it no longer remains the smaller piece, it becomes the bigger piece. Okay, so this is the maximum range. And since I want to find out the average length of the smaller piece, and I know this is a uniform random distribution, so I'll simply use the property of a uniform random distribution. I'll find out the mean for this thing. So what is the mean for a uniform distribution? So for a uniform distribution, uniform dist, my mean mu is nothing but b minus a by 2, which is b is the maximum, the maximum interval. So it's like the max of the interval, and a is the min of the interval. So if my random variable x is distributed between the interval a comma b, so my mean basically is nothing but b minus a by 2. Simply doing that, I should get my answer to be L by 4. So my answer is L by 4. I hope this question is clear. And yeah, getting the last question. So A is a positive definite matrix. What it means is that whatever eigenvalue that I get, is real and all its eigenvalues are greater than 0. And if I know that V and W are orthogonal eigenvectors of A, ATA, then which of the following is true? So all I'm given is that V and W are the orthogonal eigenvectors of A transpose A. That means I can say that V transpose of W is 0, and because they are orthogonal eigenvectors of A transpose A. So I should check it case by case, which of the following is true. So I should check if AV and AW are orthogonal. How to check that? If they are orthogonal, then I should the dot product should be 0. So I have AV, the whole transpose, and then AW. I'm just evaluating it. So if I open this transpose, I should get V of t, A of t, then there's A, and then there's W. Okay. And yeah. So since I know that W is an eigenvector of A transpose A, so if I do this, so if I know this thing, I should get some lambda W if I operate it with A transpose A. If I'm operating it with W, I should get some eigenvalue, which is lambda W, which I'm assuming. Okay. And what I'm left with is V transpose of W. Okay. And I know that this quantity is surely 0. That means this whole quantity is 0. So that means AW, sorry, AV and AW are orthogonal. So this is true. Okay. So similarly, you can check all of the other options. You can do this operation, and if it is not orthogonal, so you should, in order to prove it wrong, you should show that this quantity is not equal to 0. If they are non-zero, then it's not orthogonal, and if they are 0, the dot product is 0, then this quantity is orthogonal. Okay. So similarly, case by case, if you solve it, you can show that this option, and this option are not true. This is the only correct answer. So yeah, with this, we have, I think, covered the entire 10 questions in this assignment. If you have any doubt in any question, please feel free to unmute and ask. And otherwise, from my side, this session is completed. I have covered what I needed to cover in this 1 hour duration. If you have any question, anyone, please feel free to unmute and ask. I'll be happy to go through any question that you are not clear. Anyone? Okay.
Nope.
Okay, cool. I think with this, we conclude the week 0 assignment 1 practice questions. I hope you all had a good time in this session, and I'll see you next week when we start with the RL course, and do give a quick reading for the week 1 lecture materials, and go through the lecture contents that are there in week 1, and then I'll see you next Friday from 7 to 8 p.m. So yeah, that's all from my side. Thank you for joining. Good night. So I'll stop the record. Okay. Thank you. Bye.